everybody who is watching this fantastic video. I'm very happy to have you today. I would like to take this opportunity to welcome both international and national students in order to enjoy the beauty of basic applied mathematics in different disciplines of science and social science. So my name is Sir Olenjolai Moko Tayai Losingo, or you can call me Sir Olenjolai, that is now. I'm a Tanzanian. I'm conducting these programs from Tanzania. This is our national flag. I love so much my beautiful country. I would like to welcome all the foreigners to come and enjoy the presence of the Lord in our beautiful country. I would like to take this opportunity to welcome all our viewers in one of our online schools that called Tanzania Online Advanced Secondary School in square bracket Olenjolai. Simultaneously, we are sharing these contents by using software or digital platforms. One of the digital platforms that we are sharing these contents worldwide, however, that will be focused on the syllabus of Tanzania, is our official YouTube channel that called Tanzania Online A-Level Secondary School in square bracket Olenjolai. Well, so the next question in your mind, after I welcome you, I believe that you've taken a seat in your mind, you've already taken a seat, and then you have welcomed yourself. The next question is, what are we doing? What the purpose of Tanzania Online Advanced Secondary School? That's the best questions. Well, we are here to train and teaching advanced secondary students who are interested or who are passionate in advanced mathematics, in basic applied mathematics, or in mathematics and the advanced science. So, we are here to train them and teach them by using different teaching methodology on how they can extract knowledge, understanding, wisdom, from basic applied mathematics, advanced physics, advanced chemistry, and combine the extracted wisdom, which wisdom means applications of understood knowledge, with the knowledge, understanding, and wisdom that will teach them to extract it from the Word of God written in the Holy Bible, in order to solve real-life problems. So we are going to teach you about basic applied, advanced basic applied, basic applied mathematics for advanced students. So if you're advanced, you have to think according to your level. It means you are learning stuff which is a little bit complex compared to what you've learned during your ordinary education. According to my research, when I was an advanced secondary student, more than 13 years ago, I experienced some of the students who used to start basic applied mathematics. They are finding or they are scrabbling on how they can go through the concept and be capable to solve questions. However, that their focus was just how to get prepared or to do the fire extinguisher in order to answer exam. Well, into ASO, or just we call Tanzania Online Advanced Secondary School, we are going to train you step to step by using a very simplified language on how you can master basic applied mathematics. So if you've given up, or if maybe, because I know this is one of the subsidiary subjects according to the syllabus of basic applied mathematics syllabus for advanced secondary education, which the subject of basic applied mathematics actually is one of the subjects which is studied by the students who are not studying advanced mathematics. So I won't use a difficult or a complex language. I'll be using the syllabus of Tanzania, which teaches how we can learn basic applied mathematics in different disciplines, in science and social science, in pure science and social science. However, I'll be using the syllabus of United Republic of Tanzania, but basic applied mathematics is a universal subject. So because it's a universal subject, it means any students worldwide can benefit from these contents that I'm going to provide to you. However, that you should have your reference books or your syllabus or the syllabus of the country where you are studying, because there's a minor difference according to my research. So I would like to welcome you right now in one of the departments where that we get the subject of basic applied mathematics for the Form 6. And it's the departments of advanced mathematics. Here we are teaching you 4 subjects: advanced mathematics Form 5, advanced mathematics Form 6. For the PCM, PMC, PGM, and EGM students. We are also teaching advanced basic applied mathematics from 5 and basic applied mathematics from 6 to the students who are pursuing ECA, PCB, CBG, CBA, CBN, and HGE combinations across the entire country of Tanzania in all 31 regions, including Zanzibar and Unguja. Wow. So, in this subject of basic applied mathematics, we are in chapter 3. We have to cover 5 topics according to the syllabus, basic applied mathematics syllabus for advanced secondary education from 5 from 6. So according to this syllabus, we have to teach you 5 topics which are very important. The first one is probability, the second one is called the trigonometry, and the third one is called exponential and logarithmic function. The fourth one is called the matrices, and the last topic for the Form 6 for the basic applied mathematics for the Form 6 is called the linear programming. So this content is for pre-Form 6 or Form 6 in the following combinations: ECA, PCB, CBG, CBA, CBN, HE. E stands for Advanced Economics, and G stands for Advanced Geography, C stands for Advanced Accountants, A stands for Advanced Commerce, A stands for Advanced Accountants, B stands for Advanced Biology, P stands for Advanced Physics, and then A stands for Advanced Agriculture. This A, Advanced Agriculture, this is Advanced Accounting. Then N stands for Advanced Nutrition. Wonderful. So, and H stands for Advanced History. So you see, it's the only subject that makes students who are pursuing science, pure science, such as these students who are pursuing the following combinations, to meet with students who are pursuing social science. ECA and HE, these victims, they need some social concepts or social science concept. Well, so then, before I start today's session, I would like to remind you about how you can register yourself. Registration, right? Whenever you go in a physical advanced secondary school, on the first week or second week, you have to register yourself either in a single day or 2 days, depends to the speed of registration. How can you register yourself? Registration to Tanzania Online Advanced Secondary School, in square bracket Olenjolai. So in abbreviations is TOASO, Tanzania Online Advanced Secondary School, in square bracket Olenjolai. So the first thing should be open an email. Okay, should be open an email, and there are 2 popular emails, Yahoo or Gmail. So you can open and have your username, and also you should have your password. The second thing, then we say that we ask you that to sign in YouTube by using your email. Okay, by using your email. And then the second thing, search Tanzania Online Advanced Secondary School, in square bracket Olenjolai. When you search it, you will see an icon of just a round buttons with the Tanzania national flag. Just click it, and then you're already welcomed in what you're already in Tanzania to ASO. So the first thing, when you are watching this video or any video in our YouTube channel, then we ask you that to fill. This is the registration for the YouTube platform. So when you add another, registration to also YouTube channel. So remember that you're talking about YouTube channel. So when you add another platform, we'll let you how you can register yourself. But currently, we are using YouTube, and you are providing this content free of charge. Okay, so you have to click on subscribe. And then you have so you say that again, so you say that subscribe. Okay, so it means if you click these buttons, you click the buttons, click and subscribe, then you will be subscribed. Then you will see the bell, so you have to click this bell and have and choose the options of all. Okay, choose the options of all. Okay, so that's the first system. Then that's the first system. The fifth system, you can also create an icon which has been written to share these videos or the link of this video through WhatsApp with your classmates who you study together in primary education or study together in O-level education. So through WhatsApp, through Twitter, through Instagram, through what? Instagram, then through Telegram, and through other social media as well as you can. So if you follow those first steps, the good thing that in many physical schools, you have to register yourself every term. The good things about to also, you just have to register yourself only once for your lifetime. So if you subscribe, why should you subscribe? That's a very important question. The reason to subscribe is for you to get notification when we have, is for you to get notification whenever we add any new video. We have a plan or we have a vision to record more than 500 videos. And we'll be adding one video at least one video in a day. So whenever that, for example, we are in session 2. So when we have recorded and prepared session 3, then we'll be adding in our YouTube channel that's called Tanzania Online or A-Level City School, Olenjolai. Then you'll be notified officially by the YouTube. All of you who have subscribed will be notified at the same time that Olenjolai has added session 3 of exponential and logarithmic functions in basic applied mathematics for the Form 6. Wonderful. So I think that you have been overwhelmed with these instructions. Now let me take you into the session and I will give you some other announcement later. So let me begin with a quick review of session 1 of what of exponential logarithmic function. Basically, there are just I've reminded you that there means that topics of what? So topics of basic applied mathematics in Form 6. Okay, so in Form 6 or class 14. In some of the countries, just we call it. For example, in India, this is class 12, right? So class 12. So this country for the class 12. So topics of basic applied mathematics. So we say the first one is called what? The first one is called probability, which we teach you by using very simple language, and because many students they are not confident in probability. The second one we say that it is what? Trigonometry. So trigonometry, which is advancements of what we taught you in O-level. Then the third one, this is also advancements of what we taught you in O-level. Then the second one is called the exponential. The third topic is called the exponential and the logarithmic function. Okay. So the first one is what? Matrices. Okay. The first topic is called matrices, and the fifth one is called linear programming. So in the previous session, we have discussed about the big picture again. So we began with big picture of big picture where we get basic applied mathematics, and then we mentioned the topics, hopeful. Then we went to the what is subtopics of what? Subtopics of exponential and logarithmic function. Afterward, then we mentioned about specific objectives of what? Of each subtopic. Okay, each subtopic of what? Each subtopic of exponential and the logarithmic function. Exponential logarithmic function. So again, we say that we have also shared with you about contents. What are we going to cover? Contents of what? Of exponential and the logarithmic function. So in case you missed it, maybe you met with this session 2 at the first video of yours, don't be confused. The session or the video for session 1 is still in our YouTube channel called the Tanzania Online Advanced Secondary School, or Tanzania Online A-Level City School in square bracket OLENJOLAIM, so you can access them, or you can access the content seamless. Check. So let me teach you about, today I'm going to teach about laws of exponential function, but before I'd like just to give you introduction of exponential function. This is not a repeat, but just it is a foundation for exponential function. Introductions of exponential function. Okay? I'd like to remind you where do you get this exponential function. So the fundamental question, exponential function is the combinations of the two ways. So let me remind you what is the meaning. What is the meaning of what? Of a function in mathematics. We have a topic, functions denoted in mathematics. Coding function for the basic applied mathematics of the Form 5, which we defined or we have discussed the functions in detail. But here we just have to remind ourselves about the definitions and then we move, because we have today to deal with exponential function. Okay. So according to the literature, we say that in mathematics, a function is an expression. It can be expression. Okay, it can be expression, or it can be a rule. An expression or rule. Okay, rule or law that defines what? That defines a relationship between one variable, okay, called the independent variable, okay, and the another variable, and this another variable we call the dependent variable. So you say that that's the meaning of the function. So function in mathematics, a function is an expression or rule or law that defines a relationship between one variable, which is called independent variable, and another variable, which is called dependent variable. So you have independent variable and dependent variable. That's the meanings of function. The second question. What is exponential function? What is exponential function? So exponential function, we say that is a mathematical function of f of x is equal to a or x, where a is a constant. Which is called the base. Which is called the base of the function. The base of the function. Okay, so let me make this just called the base of the function. Okay, and it should be greater than 0. and should be greater than 0. So it means that we say a function is an expression or rule. What's a function? Ladies and gentlemen of advanced secondary education. Okay, so my beloved students, a function is an expression or rule or law that defines what? A relationship between one variable, which is called independent variable, and another variable, which is called independent variable. So example, let me give you the simple example of the function. Y is equal to x squared. So x squared is called the, let's say for example, y is equal to x squared plus 2, so a quadratic function. So x is called the independent variable, while y is called the dependent variable. So this is a function. Okay, so it's a function. So then the second question that, what is exponential function? We know now the meaning of function is a rule or expression or what, or law that defines relationship between independent and independent variable. That's all. That's the meanings of the function. Whether exponential function, whether logarithmic function, whether quadratic function, whether step function, whether polynomial function, whether we have some other functions, we call them because I mentioned the composite function. So which kind of the functions or trigonometrical function, when we'll be discussing about a natural logarithmic function, or we have different types of or hyperbolic function. So we mean it's a law or expression or rule that establishes relationship between independent variable and dependent variable. And we have to remember that in the low-level mathematics, we used to teach you that y is a common dependent variable, while x is common independent variable. But later on, especially for advanced mathematics, especially for undergraduate level or undergraduate mathematics, we'll be teaching you about y also it can be a dependent variable. It can be independent variable. So y can be an independent variable, x can be an independent variable, z can be independent variable. So it can have another dependent variable, which maybe it can be a function of x comma y comma z. That is in case you will be interested to progress with advanced mathematics. We call it higher engineering mathematics or higher mathematics. Okay. So right now, when you say exponential function, so this is the mathematical function of f of x is equal to a power x, where a is a constant, which is called the base of the function, and should be greater. This is the condition. This base of the functions always should be greater than what? Greater than 0. That's the condition. So exponential function is any function. We explain it to you. So concentrate, please. Focus. Tell your neighbor it's a time for. I believe, please, you can pause the video. Just copy these registrations instructions for you to get registered and to be an active student of Tanzania Online Advanced Secondary School. Okay, I am Sir Olenjolai. I am a national teacher who is teaching Tanzanian students who are real lovers or who have to learn the beauty of basic applied mathematics in order to apply this concept on solving real life problems. Okay. So that is the meaning. So it means that exponential function is any function which can be expressed in this form. So f of x is equal to what? Is equal to a power x. So we say that where a, this we call it the base, and x we call it what? X equal to exponent. Okay, we call it exponent. And then f of x we can call it this is value or power. So power. So the condition, remember that we say that f of x is equal to a comma power x. This will be correct if and only if a is greater than 0. So remember again, a is constant. This any constant is constant number. Can be a constant number, it depends. In most cases, A can be constant or a variable. So let me give you some few examples of exponential function. Tell your neighbor that it will show you the beauty of exponential function. Example of exponential function. So examples of exponential function, you say f of x is equal to 2 power x. Then again the other ones you say f of x is equal to 3x power x squared. Then the other ones you say f of x is equal to what? 0.4 power x power 2x, etc., etc. Okay. Okay, so those are the examples. So I want to build a strong foundations of exponential functions before I teach you the law of exponentials or law of exponents. Okay, so again we say that we have types of exponential function. This is a review of what we taught you in O level. Exponential function, types of exponential functions. Ladies and gentlemen, say types of exponential functions. Okay, so in mathematics, especially basic applied mathematics or pure applied mathematics, we say that there are two basic types of what? There are two types of exponential function. Exponential function, okay? Exponential functions. These are the first one, we call it common exponential function. And the second one is called the natural exponential function. Natural exponential function. So we have two types of exponential function. Okay, so I don't want to go into too much detail because I can deviate from the focus of this session. However, that we can access too much details of exponential function later on. Okay, so we say common exponential function and natural exponential function. Okay, so simply say that the common exponential function, so let me just explain them in brief. Common, I don't want to overwhelm you with more information, but I want you to understand. This is a trick. I'm using different teaching methodologies to teach all my students. Common exponential function. So FCT, it's abbreviations of function. Common exponential function. What is it? So simply we say that is an exponential function. Exponential function whose base is any constant number except E, and this E is 2.71 for the translation 71828, whose base is any constant. This is any constant number except this one, or variable. Any constant number greater than 0, or any variable whose value is greater than 0. Are the meanings of a common exponential function. So it's an exponential function whose base is any constant number except E, which is 2.71828, and So excuse me, saying that, yeah. So N, so let me do this minor correction. What is common exponential? Okay, so let me just start with the questions because I know that I noticed in Form 2, because I'm also teaching O-level mathematics, but we didn't teach you this concept. So let us go to question number 3. So I hear the Holy Spirit will correct me the way that I'm teaching you this concept. What is common exponential? What is common exponential function? What is common exponential function? So common exponential function, we say that is an exponential function. So we define them, so we categorize them according to the base. It's an exponential function whose base is n number greater than 0 except e, which is equal to 2.71828. Okay, except that once, okay, 8. Or n variable whose value is greater than 0. So that is, so it's an exponential function whose base is n number greater than 0 except e, or n variable whose values is greater than 0. That is a common exponential function. I know that some of the students say that, Olenjolai, you are confusing us. No, I'm not confusing you. Stay tuned. We say that. We say the general form of an exponential function, we say that is f of x is equal to a power x. But remember the condition, we say that it will be exponential function if a is greater than 0. Remember that. So we say that for the common from this general form, common exponential function, so common exponential function, we say that f of x is equal to a power x. So a power x, but when a is greater than a, so the condition is a greater than 0, and a is not equal to e. Means it's not equal to what? 2.718, etc. to 8. So this is the general form of exponential function. So let me give you examples, because with examples you may understand what I'm teaching you. I will teach you the second type, because I know the first type, common exponential function, is famous for you. We taught you during your O-level education. So let me give you examples. So these are the examples of common. All of these are examples of common exponential function. Common exponential function. First one, we say that if f of x possibly is equal to 2 power x. Second one can have f of x is equal to, because this is the function, it's not the expression. In Form 2 we taught you mostly about the exponential expression. So I'll say 3 power x plus 1. So we can have also f of x is equal to x squared. So this is the exponential function. Okay? So it's exponential function. So x squared plus what? So you can say that we have yes, we have an exponential function which is x is equal to our power under x. So this is the exponential function also. We have exponential function, so this is the variable. Now remember that x should be greater than 0, the value of x. So again, we say that we can have again 2 power 4x may be divided by 3 power 3y. So then we can have another common exponential function. So when you have x power y, let's say multiply by what? Multiply by x power log of x, possibly log of x over under it of what? Of 2 power x plus 1. So this is the exponential function, exponential function, exponential function. All of these are common exponential functions. None of it whose base is what? Whose base is equal to it. That's another type of exponential function. So in this topic, we'll be dealing with both exponential function, common exponential function, and the natural exponential function. So whenever you see all of these, we'll be dealing with certain exponential function. Also, we call them common exponential function. So let me build a foundation for you for natural exponential function before I take you into the laws of exponential function. So the second type is called your natural exponential function. So natural exponential function. Natural exponential function. So this is question 4. Okay, this is question 4. So what is, so the question now, what is natural exponential function? What is natural exponential function? Okay, what is natural exponential function? And the question, ask yourself, you can pause the video and ask yourself in your mind what the relationship, and then you can just deduce the definitions of exponential function from the definitions of the common exponential function. Okay? How? This is the process. So you see that the natural exponential function, natural exponential function. So natural exponential function, we say that is an exponential function, is an exponential function whose base is a, and this a we got the translation number e, whose base is e, and this e is 2.71828. 2.71828. So that is. So it's an exponential function whose base is what? Is e. So it means that generally we say that exponential function, so f of x is equal to e power x. Right? However, that you can have a composite exponential function, but the base should be e. Remember that. While a, this is equal to 2.71828. So e is equal to translation number, or we call it Knopelian constant. Knopelian constant, or Knopelian constant. Okay? And the good thing, you can just get this invariant constant from the scientific calculator. Just take your scientific calculator. I want to show you where you get the value of E. Okay, so to get the value of E from the scientific calculator, so this is Casio. We use any scientific calculator function or ffx. Then we have 981 ms. So how you can get the value of E? So the value of E, you have to press alpha. After you press alpha, then you press the button which is long. So there's the buttons which is being written long. So this we call it long, LN. But above here you see a E of the orange color, right? So this one now you get, so if you press alpha, E, and you press equal sign. So after all, you press the button support of equal sign. So then you get the value of translation E. Okay, so we have E is equal to 2 and 7, 1, 8, 2, 8, 1, 8, 2, 8. So that's from scientific calculation. So that's the base of a natural exponential function. Wonderful. I know it's a good news. It's the first time for you to hear about this good news in basic applied mathematics. So you have to stay enjoy it, right? Okay. So if that's the case, you have the general forms as we say. So from these general forms, you have ffx is equal to a power x. So ladies and gentlemen, let me give you some examples of natural exponential function. Natural exponential function. Natural exponential function. So the first example is we say f of x is equal to e power x. Then we go for the second example. We have f of x is equal to e, let's say, power x squared. Then you can have the third example. You can have a function exponential, natural exponential function, which is e power x plus 2. Then you can have another example where we have f of x is equal to e power ln of x. Then we can have another example where we have f of x is equal to e power x minus 2 or minus what? Minus 1. Or you can have another example where we have f of x is equal to e power log of x. Then you can have another example, we have f of x is equal to e power what? Power square root of x. We can have again another example. This is another exponential function. F of x is equal to e power what? E power x cubed. Right? We have again another example of exponential function. F of x is equal to e power cos of x. We can have again another exponential function. F of x is equal to e power what? Our tan of x, etc., etc., etc. So, ladies and gentlemen, these are the examples of natural exponential function. So, we have a good foundations of common exponential function. So, today we are adding a value. Remember that the aim of educational system and the aims of Tanzania Online Advanced Secondary School is to add value in his students. So, we want to show you the distinctions, the difference, what you know and what we want to add to you. And we add it easily in such a way that you enjoy it and you get entertained when you learn this stuff rather than get discouraged and bored. Stay tuned. Okay. So again, these are the examples of common exponential function. So we'll be using them interchangeably. When I'll be teaching about laws of exponential function, we taught you laws of common exponential function, but today I'm going to add a value in your mind that I'm going to teach you about laws of natural exponential function. All right? If you have any questions, don't hesitate to ask in the comment section. Again, I would like to tell you the good news. The good news is this one. Okay, so we are here in order to train you. So firstly, again, we don't want to train our students. We are using the digital technology to impact the mind of students of the present and future generation. So we have a good news. We were not satisfied to have an online course. Again, God has added a value on top of it that we have a responsibility to distribute materials which are effectively useful in learning basic applied mathematics. One of the, so for that case, we have Tanzania Online Advanced Library. So in that library, we have, this is one of the items, the most recommended items and the most recommended reference books that a student should have beside it, because this is the guidance. Some of the teachers in advanced secondary educations, they used to teach basic applied mathematics as advanced mathematics. Basic applied mathematics is not advanced mathematics. So the only syllabus that give us boundaries, give us what we should teach you, give us specific objectives, give us topics to teach you, give us subtopics, give us the focus of any exams ahead of you, and give us the specific objectives of every concept, and give us teaching and learning strategies. So it means that this is the syllabus. You can order a copy of this or an original book if you have in our store, then we can ship in any, means we can send this book if you buy online. Just go to the descriptions below of this video, then you can order, you can buy this book and we can send to you in any secondary school in Tanzania, regardless of whether you are in Zanzibar or Goja, we'll ship it on you. We'll ship it by using the ship, and by using the shipping mechanism just like other items. That's not enough. Again, we have a reference recommended that I'm going to use in this course that called Basic Applied Mathematics for Advanced Level Secondary Schools, Students Books, Form 5 and Form 6, prepared by Tanzania Institute of Education. Have it. You can order this book. It's cheap. And we can send to any student in any regions of Tanzania. Just go to the descriptions, read to see the link of the video to see how much does it cost. But again, so we learn about exponential logarithmic function. There's an intersection between basic applied mathematics and advanced mathematics for some of the concepts. So we recommend this book called The Pure Mathematics One by J.K. Backhouse, which used by advanced mathematics students, but will be guiding. It means if you read this one, don't read everything. Just read about the guidance of the syllabus. This is the third weekends that we are recommending to you. Again, we are not satisfied. We want to prepare. We know our students will be having a certificate secondary education examination of basic applied mathematics. When you are in Form 6 right now, we are getting prepared for that. We have a pre-mock, we have mock exams. So we want to prepare also our students, and we combine our teaching with what we call in university tutorial questions, but here we call it questions and answers or past papers questions. And this is Basic Applied Mathematics Review Book, which is Problems and Solutions from 2001-2016. These are questions and answers. Possibly answers or possibly the solutions might not be right. That's not the case. The issue is use this book to know the arrangement of the questions and to know what are you going to tackle or what are you going to face in your final examinations for advanced certificate secondary education examination in Tanzania or in any country. So you can order all of these books at the package. There's a great discount. We are not doing business. We are servicing our students. We want to equip you. Teaching itself is not enough. We want also to teach you the techniques of using these books, and you can go through them in 2 years or within the manifest in 2 years or within the specific times and cover everything that you are supposed to cover without too much of hassling. That's why here we are. So please click the buttons written show more. Okay, show more. So when you click these buttons of show more, it will take you into descriptions of this video. You see the link we added for this book or for Tanzania Online Advanced Library. Don't wait. Just click there in order to have this stuff. Okay, may God bless you. So let us proceed. So we ended in natural exponential function. So I told you what the meaning of the function. I told you what the means of exponential function. I told you what are the two basic types of exponential functions in mathematics. And we said we have common exponential function and we have natural exponential function. I told you what the means of common exponential function. And I told you what the means of natural exponential function. That was not enough. I gave you examples just to illustrate and simplify the concept of common exponential function and common and natural exponential function. Right now, it's the time I want to teach you the theme of the sessions, like laws of what exponential function, right? So I'm going to teach you because now you know what the means of exponential function and what the means of logarithmic function. I have almost about 60 laws. Okay, so 60 here, 6 laws. And these are the basic laws we'll be adding. We'll be learning. If you take a career of basic mathematics, basic applied mathematics, then so now we'll be learning these more laws. So laws of exponential function. So remember, whenever we say exponential function, we mean both natural exponential function and the common exponential function. And there's a difference between function and the expression. Okay, laws of exponential function. Okay, there's a difference. An expression is, for example, you have 2x. That's an expression. A function, we say that 2, for example, y is equal to 2x. This is an expression, this is a function. And this is equation, this is not equation. Okay, how to differentiate that. Laws of exponential function. I don't want to waste much of your time. Let us start with law of product, and we are going to practice them soon. Law of product. Okay? Law of products or law of multiplications of exponential function. So law of product is if you start with what? If you start with common exponential function. Common exponential function, we say if you have a power x, then we multiply with a power y. This is equal to, if you multiply to exponential function of the same base, this is equal to what? To adding the exponents, means a power x plus y. Okay? Again, we say that for the natural exponential function of product, how will it be? We have e power x, then we multiply with e power y, because we say that the base of the natural exponential function is always e. So here we are going to add the exponent. So e power x plus y. Wonderful. Those are the two laws. My dear students, I would like to ask you to keep these laws because we are going to use them often in this session. So keep these laws because you'll find them. You'll find that we need them in most cases. The second law, we call it law of what? Law of division of exponential function. So law of division, I will give you examples, don't worry, and we'll apply those laws. We taught you this law during your Form 2, the first chapter called exponential radicals. You remember? Just how many years ago? 3 years ago. Is it? 3 years ago. 3 years to 4 years for some of the students. So we have what? 1. So when you have a power x, then we divide with a power 1. So we have two exponential functions of the same base, and then we divide them. This is equal to, if you have a times a power x minus 1. Okay? And then we say what? We say what? Also for natural exponential function, we have e power x divided by e power 1. This is equal to e power x minus 1. Okay, that's law of division. Okay, another law. law of expressing exponent in a singular. Law of expressing what? So you say that this is still law of product. Okay, law of product. Say law of single exponent. So the law of single exponent, we say that if you have a power x, you multiply with a. No. You multiply with another base, it's another exponent with a different base, which is b power x. Then this is equal to a times b power x. So we change two products of the two exponential function into simple exponential function. But this is common exponential function. Similarly, for natural logarithms, you cannot have that ones because remember that for the natural exponential function, if you have e power x, then we have e power x. Simply this one is equal to e power 2x because the base is the same. Right? Means e power x plus x, which is 2x. Then we have again another law. Okay, so the next law is what? Again, we have what? We have a power x times what? Hence, open bracket a power x times 1. So you can open this bracket and multiply the exponent. So this is equal to a power x in 1. So a power x in 1. Okay, so for the natural exponential function, here we have e power x times what? Times 1. So this is equal to e power x in 1. Wonderful. Again, we have another one. We say that if you have a power xc over a power xc, if you are dividing the same exponential function or exponential expression, then the answer is equal to 1. Okay? It's equal to 1. Why? Because this is equal to 1. Why is equal to 1? Because remember that this is equal to a power x minus x. And the answer is equal to a power 0. So a power 0 is 1. Any number power 0 is equal to what? Is equal to 1. Okay, so then we say that also in case you have e power x over e power x, the answer is equal to 1. But again, here we have to establish this rule. A power 0 is equal to 1, and also e power 0 is equal to 1. And any number power 0 is equal to 1. So if you have 2 power 0 is equal to 1. Remember that. Okay? Then we have the sixth law. The sixth law, we say that if you have a, this negative indices, a power negative x, this is equal to 1 over a power x. 1 over a power x. I say, the rules say that whenever we have a power negative x, this is equal to 1 over a power x. This is the law of exponent. That's what I've explained here. Similarly, for the natural exponential function, whenever you have e power negative x, this is equal to 1 over e power x. Even if plot the graph, you'll see this behavior. Okay? Why? Because remember that a power x, it means 1 over a power x. So where do we get this? Remember that you have 1 over 2. So 1 over 2, in other words, you say that this is 1. Or you say that, okay, so this is 2 or negative 1. So if this is true, it's true also for x1. Or whenever we have 3 power negative 1, this is equal to 1 over 3. That's a fact. Just use the scientific calculator. Take 3 power negative 1, find its value, and take 1 over 3 and find they have the same value. Okay? So these are the laws. Okay. So again, do you have any other law? Okay. The last law, 7, this is for exponential. Say that if a is greater than 0, then a power x is also greater than 0. If a greater than 0, then a power x is greater than 0. This law is not applicable for natural exponential function because the base is always greater than 0. It's the same value, 2.712, no, 2.71828, and etc., etc., etc. So those are the laws. So let me give you one example. Example, so this is example 1. Identify the base and exponents of the following. Identify the base and the exponent of the following. So you'll be given two functions, a, f of x, two exponential function. This is common exponential function, 2 power e power, no, natural exponential function, e power 2x plus 3. Then the other one, b, we say that f of x is equal to a half power of x. Solution. So tell me, which is natural exponential function between a and b? And tell me in the comment section, which is common exponential function between a, comma a, and comma b? Okay. Solution. So the question asks us to identify base and the exponent. Okay. So the first step, say that you have to recall the basic form, general form of exponential function of what is. So this is a of common exponential function of natural exponential function. So the general form we say that is f of x is equal to e power x. So we say e, this is base, and then x, this is exponent. Then f of x, this is power or value. Okay. So now, so for Roman A, we will be given f of x is equal to a power 3x plus 3. So the question asks us to find base. So we say base, this is equal to e. Base is equal to e. And the exponent is 3x plus 3. So this is second step. You have to apply or to record. Then we go for the third step. So we have to record the general form of common exponential function, which f of x is equal to a power x. A stands for base, and then x stands for exponent. So now we have a half power x. So for that case, you say that base is, for this case, base is a half, and the exponent is x at the response. Okay, so that is. So then, let me do example 2, which you have to refer, basically applied mathematics book. So basically applied mathematics for advanced level, A level book. Okay. Exercise. Exercise 9.1, page 200. For international student, 91. Just ignore this. 276. Just ignore the book because the book is not sold. Okay, yeah. Okay, you may decide. The question says that write the base and exponent of each of the following. Write the base and the exponent of each of the following. Write the base and write the base and exponent of each of the following. Then you say A, we have f of x is equal to 3 power x. Then B, we have f of x is equal to b power x plus 2. Then we have C, f of x is equal to e power 2x plus 3. E power 2x plus 3. So for this case, I'll leave this one as homework. Solution. So Roman A, it's your homework. Or it's a quiz, not a homework, just it's a quiz. So try. So quiz means you have to try yourself. Just pause the video and then tell me the base and exponent. This is just a quiz, you have to do it in the class. So quiz, try. Tell me, write the base and exponent of f of x is equal to 3 power x. Pause the video and then write it. I believe that you are done. So let's do correction. Okay? So correction. So correction of the quiz, we say that the first step, we say that you have to recall, you have to check is it a common exponential function or natural exponential function. This common exponential function. So the general form we say that we call f of x is equal to a power x. So then we say that what a is equal to base and then x is equal to exponent. Okay? Then for that case, you say that base is equal to 3 if you compare, right? It means that you say that the second step, compare, okay, right. So suppose that this is, let me give you the flow of solving questions, okay? So compare, so in question 1, we say that a is equal to base, while x is equal to exponent. So we say that the second step, when you record that general form, say that we have to compare question 1 with what? So we have to compare question 1 with the given f of x is equal to 3 over x. So if you compare, so you find that a is equal to 3 and x is equal to x. So base of exponent is 3 and exponent is x. That's for 1a. Let me do for b. B is f of x is equal to what? Is equal to b or x plus 2. Right? So is this a natural exponential function or logarithm? Is it a natural exponential function or common exponential function? We don't know because we don't know the value of b. Okay? But the base is not b, unless that the value of b is equal to b. So in this case, we say that if it's the case, let's take this as question 1. So we say that we have to compare with what? Compare with f of x is equal to 8 over x. So you find that base, which is equal to a, is equal to b for that case, and the exponent, which generally is equal to x, for that case is equal to x plus 2. So therefore, we say that base and the exponent of exponential function of f of x is equal to b over x plus 2 are b and the x plus 2 respectively. At the response. So for Roman C, that's your homework. Do it, Roman C. So let us go, or let us solve some questions or some problems. Let's solve some problems of what? Some problems of using the law of exponent. So this is example 3. Refer the same book, Best Applied Mathematics for Advanced, which you got for A level, 45 and 6 book. Exercise 9.1, page 276, question 4. This one was question 1. to the Tanzanians. Very simple for you to get this reference. For international students, if you don't have access or you don't need this book, just focus on the question. Because this question is universal. It's not just for the Tanzanian. Use properties of exponents. Use properties of exponents to simplify each of the following expressions. So these are not functions, these are expressions. The first one, it is a power y plus 2 power negative y squared minus 2 power y minus 2 power negative y squared. D P plus 3Q plus 2, then P Q minus 1 squared. Then P plus 1 power 3 power 2. Then C x power 3p plus q, and then x power 3q plus p over x plus p squared. Use properties of exponents to simplify each of the following expressions. Solution. To simplify, we have to use the laws of exponents that I told you. With a bar y, so we have a power y plus 2 power negative y, and then square minus what? 2 power y, then minus 2 power negative y square. Alright. So if you check this, we have to use the following laws. The first step, say that we call the law which you have learned that a power x then times y, this is equal to a power xy. Okay, so if you have a power y plus what? 2 power negative y square, this is equal to what? A power 2y plus 2 power negative 2y. Then we have what? 2 power y. We say that this is minus 2 power negative y squared. This is equal to what? A or 2 power 2y minus what? 2 power negative 2y. So we have a power y plus 2 power negative y squared minus what? 2 power y minus 2 power negative y squared. This is equal to what you have here, a power 2y. So this is the second step. a power 2y, then plus what? 2 power negative 2y minus 2 power 2y minus 2 power negative 2y. So then we say that we have to collect like terms. Suppose that this is equation 2, expression 2, and this is expression 1. So the steady step, simplify expression 2 by collecting the like terms. So to simplify, we say that this is equal to a power 2y minus a power 2y. A power 2y. Then we say that plus what? 2 power negative 2y. Negative is positive, plus plus 2 power negative 2y. Okay? So same base, same exponent. So the answer here is 0 plus. Then can we add? If you let this is equal to a, it will be 2a. So 2 power negative 2y. If maybe can make you, okay. So if you add this one is equal to 2 power 2, no 2 times 2 power negative 2y. Okay. So therefore, a power y plus a, is it a or 2? Excuse me. Let me check. It's a. Oh, excuse me. This is a. This is a. Okay. Point where I did a mistake is here. This is 2 power 2y. A power 2y plus 2 power negative . Is it possible to collect the like terms? So a power 2y minus 2 power 2y. And then save 2 power negative 2y plus 2 power negative 2y. So this, so here we have a, so the remains a power 2y minus 2 power 2y plus what? So this one, if you add, you get 2 times 2 power negative 2y, because these are the like terms. Base the same, exponent the same, so we can add. Then here, 2y is common. So we can have a power negative 2 power 2y plus 2 power what? So you can have even 2 power 1, then we multiply with 2 power negative 2y. So if you keep on simplifying, we have a minus 2 power 2y, then plus what? 2, 1 minus 2y. So therefore, a power y plus 2 power negative y. If you use
properties of exponent, minus what? 2 power y minus 2 power negative y. This is equal to a minus 2, single base, is 2y. Then plus what? 2 power 1 minus 2y. This is the response
of Roman A.
Then B, it's simple. Just have to apply the same principle. And even this one is simple. So B is your homework, and C is your homework. Just use the laws.
So now let me teach you the last concept. I believe that you can pause the video to copy, or you can rewind it to copy the solution. So I want to leave the homework for you there. So example, what? So example 1, 2, 3, example 4 right now. So example 4. So refer the simple. So refer BAM for A level 4. But this is the example. The question asks you that solve for x. Solve for x from the following. Solve for x from the following exponential question. Exponential question. We have been given 3 power x squared minus 5x plus 2. Plus 5x plus 2 is equal to 9 power x plus 1. So you have 3 power x squared minus 5x plus 2 is equal to 9 power x plus 1. Solve for x, not a question. So solve for x, we have to, the first step, how to simplify what? How to simplify the given expression, which is 3 power x squared minus 5x plus 2 is equal to 9 power x plus 1. So to simplify, first of all, 9 is equal to 3 and 3 is equal to 3 squared. So then you have 3 x squared minus 5x plus 2. This is equal to 3 squared and then x plus 1. So for that case, you say that this is 3 power x squared minus 5x plus 2. This is equal to what? Is equal to 3 power 2x plus 1. Right? So you say that suppose that this is equation 1. So this is equation 1. So this is equation 2. So second step, we say that you have a law again of the same base. We say if you have a power x is equal to a power y, we are allowed to cancel the base and remain these exponents. So if you have a power x is equal to a power y, same base, we cancel exponent, we remain with exponent. We cancel the base of the exponent and remains with exponents. So if that the case, you have 3 power x squared minus 5x plus 2 plus 2.
this is equal to what? Is equal to 3 power 2x plus what? Plus 1. So 3 power x square minus 5x plus 2 is equal to 3 power 2x plus 1. So same base, have to cancel. Then we have x squared minus 5x plus 2 is equal to 2x plus 1. So you have to simplify again. So this is question 3. So the third step, we say that solve for x in equation 3 above. So here we have x squared minus 5x minus twice x plus 2 minus 1 is equal to 2x minus 2x plus 1 minus 1. So ladies and gentlemen, we have x squared minus 7x and then plus 1 is equal to 0. How you can solve? So simplify, not solve first of all. So simplify equation 3. So here we have equation 4. So the next step is the fourth step. We say that solve for x. By using your scientific calculator, by using splitting the middle term, by using perfect square, by using general formula, by using graph, by using matrix you cannot use, by using graph. So if you use your scientific calculator, you'll find that when I say scientific calculator again, in our library, in TANZANIA Online Advanced Library, we have also beautiful scientific calculator. We're not doing business, we are providing service. We want to equip our students with every material that is required for them to go through beyond the syllabus and beyond the curriculums, and especially to think how they can apply this knowledge to solve real-life problems. So you need a scientific calculator of Casio function 991 is recommended, or function 9 or Casio function 100 is recommended for basic applied mathematics. So you need it. Don't wait right now. Just click the buttons of show more to go to the descriptions to see the link of the video and see the different prices of buying this scientific calculator with a very reasonable costing, very minimum costing. Because just we are selling you the same costing, the same price at the price of the local shops, or even lower than that, because we want our students of the different financial status to have a scientific calculator for them to master basic applied mathematics for the rest of the year. So if you use the scientific calculator, you have x is equal to 0 and x is equal to 7. So how do you use it? So you have to turn on your scientific calculator, press mod for the first time, mod second time, mod third time, then you have a question, then just press the play button, then we have to deal with 2 degrees, then coefficients of A is 1, coefficient of B is -7, coefficient of C is 1, then press equal sign. So approximately x is equal to what? Approximately x is equal to, wait. There we had 2x, choose me. So here if you expand, I made a mistake here. So it is 3 power 2x plus 2. And here we have 2x, means 3 power 2x plus 2. So this is 2. And here we have what? So plus 2 minus 2. So here this is minus 2. So simply this is 0. So you have x. So simply we can solve this question easily without even using the scientific calculator. So you have x squared minus 7x is equal to 0. So take x out because it is common. So it is x minus 7 is equal to 0. Compare. So x is equal to 0 and the other value of x is equal to 7. So the question asks you to solve for x. So these are the two values. of X.
Let me leave it the homework. So this is the general homework right now. What should be example? Because that one was example 4. So example 5, this is homework. Homework 2. Okay? So question said that refer best applied mathematics book. So refer this book, this one, and this is the exercise. See the exercise, so you can pause the video. So this is the exercise, but next time you have to read yourself. So this is the exercise 9.1, and these are the other questions. So say that refer best applied mathematics students books for advanced level, for A level, for A level secondary school, secondary school, okay, secondary schools, exercise 9.1, page 276, 277. No, only 276. Let me say do or do question 2, 3, and 4 and 5 in that exercise. When you are done, submit your homework 2 in comment section below. Comment section below. In comment section. Okay, of this video. Ladies and gentlemen, my father who is never said that Olenjolai is enough. It's enough for the best laws or for the laws of exponential function. I thank God who have been with me in the preparations of this idea, preparations of this session, preparations of this, preparations of Tanzania Online or Advanced Secondary School. I thank God who have created me in His own image and likeness, and I thank God who have been with me in preparations of session 2, which titled as Laws of Exponential Functions. May God bless you abundantly. I thank God also who have given you opportunity to join me. I would like to invite you in session 3 when I'll teach you about basic properties. I'll be still teaching about basic properties of exponential function, where I will be focusing about graphs of exponential function, and also I'll teach you about some other properties, okay, of exponential functions. Very important for you. Don't miss. Invite some advanced secondary students who are pursuing those among those 6 combinations. So invite any from 60 students who is studying ECA or PCB or CBG or CBA or CBN or HGE in order to enjoy the beauty of basic applied mathematics for the Form 60. And once again, remember that to click the buttons of show more to read more descriptions, and also have the link of how you can order books online by using the digital platform in Tanzania Online Advanced Library. Again, remember to subscribe into our YouTube channel for you to be registered permanently in our channels and get information once we upload a new video. Don't wait and don't miss, and share these contents to any advanced secondary students of the Form 60 in Tanzania or internationally or in any country of African continent about the good news. Finally, If you feel from your heart that you want to offer our living God the freewheeling Thanksgiving through this program, you're warmly welcome. There's a high running cost for these programs. Whenever we prepare one video, we will spend large amount of money in order to prepare and distribute it into different platforms. But God is a sponsor of this program. He didn't give me permissions to charge you any amount of money, but the door for you to offer your freewheeling Thanksgiving from your heart through this telephone number 0759745331. In case you want to do bank transaction, go to the descriptions, you'll see the bank account and bank name. Until I meet you in the next session, which is session 3, this is Olenjolai from Tanzania. May God bless you and keep you until we meet in session 3, where we are going to learn about graph of exponential function, common exponential function and natural exponential function. So may God keep you until I meet you. Stay enjoy the beauty of basic applied mathematics for the Form 6 students or for the class 12.